Hi everybody, let's go over some scatterplot vocabulary. Actually, you've heard me use some of these words in previous videos, so you might be familiar with some of the words that I'm going to talk about already. The first word is outlier. An outlier is a point of data on a scatterplot that does not fit the trend shown by the other points. So you've seen these scatterplots already. I used them in a previous video. So if I were to draw a quick trend line through this scatter plot over here, it might look something like this. Draw one through here, it would look like that. And through here, it would look like that. Okay, and it's pretty easy to spot the outliers, like this guy over here, this one over here, and this one over here. They don't seem to fit the trend that is shown by all of the other dots. So for example, over here, if I spend more hours at the gym, then it looks like I burn more calories. Except over here, this person spent a lot of time at the gym, but did not burn so many calories. So that would be an outlier. That person doesn't seem to fit the same pattern that is shown by all of the other points of data. So I actually talked a lot about that in a previous video using the exact same examples. So I'm not going to dwell too much on that. Let's just move on here. To positive and negative association, or another word for that is correlation. So a positive association between two variables means that as one increases, the other also increases. And as one decreases, the other one also decreases. So over here, I didn't really have to erase those trend lines. But over here, I can see that generally speaking, except for this outlier guy over here, the more time I spend at the gym, or the more time a person spends at the gym, the more calories they burn, generally speaking. So for example, this person over here spent a little bit more time at the gym than this person over here, but this person's burned actually less calories than this person. But generally speaking, if I were to draw a trend line through this data, the more hours a person spends at the gym, the more calories they burn. So as the number of hours increases, the number of calories also increases. And if we were to draw a trend line through a scatter plot which shows a positive association or a positive correlation, then we would see that the line has a positive slope. So as we move from left to right, the trend line is going up. Okay, and a negative association is sort of the opposite. A negative association between two variables means that as one increases, the other decreases. Also, as one decreases, the other increases. So if I were to draw a trend line through these dots over here, we can see that generally speaking, if a person spends more time surfing the internet, so moving this way on the x-axis, they're spending more time surfing the internet, you can see that their GPA is going down, 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 right? So that would be a negative correlation. As the hours surfing the internet increase, the GPA decreases. Or you could go the other way and say that as the hours surfing the internet decreases, then the GPA increases just like that. Okay? So that's another, also as one decreases, the other increases. And by the way, going back over here to this one, we could also say as one decreases, the other decreases. Okay, so if I spend less hours working out at the gym, then the number of calories that I burn goes down. Okay, so, all right, so I think that's enough for that. This one would also be a positive correlation. So for a negative association or a negative correlation, if you were to put a trend line through it, then the slope would be negative. So as we go from left to right, a negative association would have a negative slope. The line would be going down. Okay, so let's continue to linear and non-linear associations. So the association between two variables is linear when it is approximated well by a straight line. So here there is a linear, I didn't draw that very well. I keep drawing the same line over and over again. I should tell myself just stop erasing this trend line, and then I won't have to draw it a million times. Okay, so we can see that these dots over here are approximated pretty well by this straight line that I drew for the 10th time. Okay, so all of these dots over here, all of these scatter plots would have a linear association, because if we just ignore the outliers, then a straight line seems to give a good approximation of the trend that we see. But let's take a look at a scatter plot where a straight line would not give us a very good approximation. So right over here, I have a scatter plot with years on the x-axis and population on the y-axis, and that's hard to see, but there's a B there. So this is 1B, 2B, 3B. That B stands for billion. So this is the world population versus years, and the population is measured in billions of people. So you can see in the year 2000, there were just over 6 billion people in the world. Okay, and then going back to the year 1800, there were only about 1 billion people. So that wasn't too long ago. That was just a little over 200 years ago. Unless my videos are so popular that you're watching this 5,000 years in the future, then maybe it would more time for you. But from where I am now, making this in the year 2020, the year 1800 was only a little bit over 200 years ago. I assume people are still going to be watching my videos in the year 7000 or so. Anyway, so over here, if we were to try to approximate this with a straight line, we could try to draw something like this, and we could sort of kind of get it, but we can see that really here a straight line is just not doing a very good job of saying what the relationship is between years and population. The relationship, the population doesn't go up in a linear fashion as the years go by. Okay, so a better approximation for population would be something like this, which is an exponential curve. It stays not too steep for a while, and then it kind of shoots up really quickly. That would be an exponential curve. So not all data, not every scatter plot that you're ever going to see can be approximated very well with a straight line. You could try to put a straight line in there, but it's not going to really do a good job of showing you what's happening. So you might have to use, an exponential curve or a parabolic curve, or just something else, something other than a straight line. So if a straight line does a good job, like it did back here, then we would call these associations linear. If a straight line does not do a good job, then it would be non-linear. Okay, so moving right along, a cluster. A cluster is where a large number of data points seem to be grouped together. So let's take a look at this graph, which I took from Khan Academy. They had a good example there. So this is we're measuring here a certain type of fish. So each dot here represents a different fish. So maybe I reach my hand into the water, I pull out a fish, and then I measure the length of that fish in centimeters, and I measure the weight of that fish in grams. Actually, technically, grams would be a measure of mass, not weight. So I'm going to throw a little science in there, but close enough. So if I'm measuring the the length in centimeters. I put my hand into the water, I take out a fish, I measure the length of it, and then I weigh it, and I see how many grams it would, or really what the mass is in grams. And then I put each individual measurement of the length and the weight for each individual fish. Remember, each of these dots represents a different fish that I pulled out of the water, like Gollum from the Lord of the Rings. Okay? And we can see here that what's happening is we're getting a cluster over here, and we're getting a cluster over here. All right? So there seems to be a group over here and a different group over here. I don't seem to be getting anything in the middle. I don't seem to be getting any fish that are, say, 8 centimeters long with a mass of 40 grams, right? They're either very long and weigh a lot, or really that's not really a lot, but maybe it's a lot for that particular kind of fish, or the length is very short and also the mass is very low. It's either one of these two things. So I have two clusters over here. Here's one cluster, here's another cluster where all those data, they seem to be grouped together. And if I see something like this, I might be wondering why I'm getting data like this. What's going on? And here's an explanation of what's going on in this example. So what is this specific fish? So this is again from Khan Academy. The adult male I'm going to do my best here. Adult male Lamprologus calipteris, a type of fish, are much bigger than their female counterparts. They weigh about, okay, so something went wrong here when I, hang on a second. All right, let's try that again. That didn't copy very well when I copied it. So adult male Lamprologus calipteris, a type of fish, are much bigger than their female counterparts. They weigh about 13 times as much. Also, while females reach a length of 6 centimeters, males reach a length of 15 centimeters. So now I see what's going on over here. These were all the male fish that I pulled out of the water, and this cluster over here is a cluster of female fish. And these clusters could be very useful to me. If I pull another fish out of the water and I measure the length and the mass, then I could easily tell what type of fish I have. Do I have a male fish or do I have a female fish, by seeing what cluster it went into. So for example, if I reach in again and I measure the fish and I see that the fish has a length of 13, let's say 13 centimeters, and it has right, so there's 13 centimeters there, and it has let's say a mass of 70 grams, then I could say, oh, okay, so based on that information, if I plot it, I can see that it's in this cluster, so that must be a male fish that I just pulled out of the water. So clustering can be useful for categorizing, the gender of some animal or different species or whatever it is that we're talking about. Okay? All right, so that's it, and have a great day.